Uh, Again, welcome to lecture fact and power quality. In the previous lecture, we were discussing about the STATCOM. So STATCOM is a basically a shunt compensator which is connected at the center of the line. It may be sending end, receiving end, but it is connected in parallel. Basically, it is a current injecting in quadrature with the phase quadrature with the voltage. So as long as the component of current in phase quadrature, either it is going to consume reactive current or it is going to supply reactive current. It has two type. Already we have discussed. This is just I am taking a review. There is a it has a voltage source converter or current source converter. This diagram, it is for the voltage source converter, and the second diagram, it is for the current source converter. Okay, this is already considered in the last lecture. Next is the static var compensator. Static var compensator, it is also connected. All these static var compensators are connected in series, in parallel, and it is less costly as compared to the STATCOM. A shunt connected static var generator or absorber whose output is adjusted to exchange the capacitive or inductive current as to maintain or control a specific parameter of electrical power system. So there are different type of static var compensator. This static var compensator, it may be say we can say that just a minute. Okay, it may be a thyristor control. It may be a thyristor control. It may be a thyristor control reactor or thyristor switch reactor. Just a minute, it is something. Okay, so this is either it is a thyristor control reactor and thyristor control thyristor switch reactor and thyristor switched capacitor. What it means, when the reactor is connected with the SCRs or some thyristor control units over there, so we can control the reactance values in a smooth manner. And when it is possible to control the value of reactor smoothly, then it is called as a thyristor control reactor. And when the when the reactor value, it is going to control in steps, either some just like a switch. Say for example, this is one reactor, this is second reactor, okay, third reactor, and it is controlled with the help of some selector switch. So the reactor value, it is going to change in steps wise. So say 100 MVR, 150 MVR, 175 MVR, it is going to select with the help of different selector switch position number 1, 2, 3, and so on. So under such condition, if the value of reactor is going to control in step, it is called as a thyristor switched reactor. Now similarly, the capacitor value cannot be controlled smoothly. Therefore, it is always thyristor switch reactors. Thyristor switch capacitors are they. So this is the two different value. It is already explained, so we are not going to inside the this value. Okay. Now this is the this So now thyristor controlled reactor, TCR, a shunt connected thyristor controlled inductor whose effective reactance is varies in continuous manner by partial conduction control of thyristor wall. So by partial conduction of thyristor wall, it is possible to do the smooth control. How it is? Say just say for example, if you are going to change the firing angle, this much portion of waveform is going to conduct, isn't it? And when this much portion of waveform is going to conduct, it means that it is possible to control the reactive value very smoothly, isn't it? And hence, therefore, it is called as a thyristor controlled reactor, and this is done by the thyristor walls are there. Now, similarly, thyristor switched reactor, a shunt connected thyristor switched inductor whose effective reactance is varied in stepwise or step-wise manner by full or zero conduction. Either you are going to conduct zero value, means when alpha or the firing angle is equal to 180 degree, then it is called as a switch off, isn't it? And when the firing angle is equal to zero, full conduction of waveform is there, and therefore it is called as a thyristor switch reactors. Either it is going to conduct or it is going to stop conducting. So therefore it is called as a thyristor switched reactor. Next, it is the thyristor switch capacitor, a shunt connected thyristor switched capacitor whose effective reactance is varied in step manner by full or zero conduction operation of the thyristor's wall. So here the capacitor value, see in the previous slide, I'm facing some difficulty in annotation. So okay, so here the capacitor value, it is going to change with respect to the either zero conduction or full conduction. So this is the some shunt connected controller. Now series connected controllers. This point to be explained in detail. Similar to the STATCOM is connected in parallel, and series connected controllers or static synchronous series compensator, it is connected in series with the transmission line. And it is found that in India, most of the FACT devices which is connected in the transmission line, existing transmission line, and some project which is going on for the FACT devices or FACT controller, it is also connected in series. It is going to connect in the series. A static synchronous generator operated without an external electric energy source or as a series compensator whose output voltage is in quadrature with and control independent of the line current for purpose of increasing or decreasing overall reactive voltage drop across the line and thereby controlling the transmitted electrical power. So try to understand. See, as it is connected in the series with the transmission line, see here it is connected in series with the it is connected in a series with the transmission line, and when it is connected in the transmission line, it purpose to inject the voltage in phase quadrature of the line current. As long as the injected voltage in phase quadrature with the line current, either it is going to supply or consume reactive power and hence improve the voltage profile of transmission line. It means that it is going to inject the voltage in series with the transmission voltage so as to maintain the dips or decrease in voltage of the transmission, isn't it? It is found that as the transmission line length is going to increase, the voltage drops are there, and that voltage drop, that reactive voltage drop, it is going to enhance or it is going to suppress with the help of series compensator. Now, as long as the injected voltage in phase quadrature, it is going to supply reactive voltage and reactive voltage. Either it may be a inductive reactance type or it may be a capacitive reactance type. But as the angle, it is not exactly 90 degree, but less than 90 and more than 0. Under such condition, it is going to supply the active power also, isn't it? Second, whatever the injected voltage is independent of say current in the transmission line. So it is just analogy to the STATCOM. Okay. Now again, there are two type of controllers are there. Either it may be a voltage source converter and it may be a series source converter. So here it is a voltage source converter. A charge capacitor has been shown, and when there is a series static series type controllers are there, under such condition there is an inductor. But cost point of view, voltage source converters are generally used in the system. Now, thyristor controlled series capacitor. Earlier we have discussed that thyristor controlled series thyristor controlled shunt compensator, isn't it? Either it is a inductive type or it may be a capacitive type. Similar way, thyristor controlled series capacitors are there. Thyristor controlled series capacitor. Earlier we found that thyristor switched capacitor. So see in this diagram, this is the line whose we are going to introduce a fact device. This is the capacitor. This is the capacitor or capacitive reactance which is included in series with the transmission line. What is the purpose of including the transmission line inductor? See here, as we come to know that the power transmitted is equal to E1 E2 divided by total transmission reactance X into sine delta. Sine delta. This is the equation for power handling capacity of the transmission line. To enhance the power handling capacity of the transmission line, either sending end voltage or the system voltage can be increased, but there is some limit because of the biological effect over the human beings and animals. Those are grazing over there. So we cannot increase the voltage more than 765 kV. Still in India, some of the lines are 765 kV either, and most of the transmission voltage or grid voltage is 400 kV. So this is the some particular limit of the transmission voltage. Whereas the reactance X can be decreased with the help of bundle conductor parallel transmission line. Now suppose a capacitor is connected in series with the transmission line. What happened? This is minus XC. This is say a transmission line voltage XL minus XC. It is the difference of these two values. It means that it is possible to decrease the reactance of the total transmission line, isn't it? Therefore, series compensation, it also called as a line length compensation. It means that virtually we are decreasing the length of the transmission line. Okay. So here the capacitor, we want to change the value of capacitor, but as told earlier, the capacitor value cannot be changed in a smooth manner. Means we cannot change similar to the reactor value in a smooth manner. Therefore, this part, it is nothing but the thyristor control reactor. This part is thyristor control reactor. See in the previous diagram, this is the thyristor control reactor. So what we are doing, we are connecting a small thyristor control reactor in parallel with the capacitor. As the thyristor conducting 100%, what happened? The capacitor, it is not going to use in the transmission line, whereas the inductor is introduced in the transmission line. When the thyristor is off, means the conduction angle is equal to 0. Firing angle is equal to 0. Under such condition, the whatever the value of capacitor, it is get included in the series of the transmission line. So it means that by controlling the firing angle, it is possible to obtain the variable impedance of this much circuit so as to obtain the control parameter over the transmission line. Is it clear? So a capacitive reactance compensator, which is consist of series capacitor bank. This is the series capacitor bank shunted by the thyristor controlled reactor. It is shunted by the thyristor controlled reactor in order to provide the smooth variable series capacitive reactance. It is already told that the capacitor cannot be controlled in a smooth manner. Either it can be thyristor switch reactor, but with the help of thyristor controlled reactor shunted in the capacitor, it is possible to obtain the smooth variable series capacitive reactance. The TCSC, that is a thyristor control series compensator, thyristor control series capacitor is based on thyristor without gate turn off capability. Here, whatever we are using the thyristor walls, it is a without gate turn off. It can be turned on with the pulse, but cannot be turned off with the help of pulse. Okay, it is an alternative to the SSC. Why? It is the again similar to the STATCOM. In case of STATCOM, we are able to use some static watt generator similar to the SSC, which is a costlier as compared to the TCSC. So TCSC cost is smaller as compared to the SSC. Okay, it is important to fact controller a variable inductor such as thyristor controlled reactor TCR is connected across the series capacitor when the TCR firing angle is 180 degree. Means here the TCR angle is 180 degree. What happened? The reactor become a non-conductive. This reactor become a non-conductive and entire current is going to flow from the capacitor. Okay, so it become a non-conductive and the series capacitor capacitor has its normal impedance, whatever the capacitor value is there, and therefore P is equal to E1 E2 XL minus XC. Now here we want to change the value of XC as per the requirement. Okay, that XC can be changed with the help of firing angle, change in firing angle, and the controlling of thyristor controlled reactor. So this is the case by which it is possible to control the capacitor which is connected in series with the transmission line for the series compensation. Okay. Now, similar to the this is a thyristor switch series capacitor, similar to the thyristor switch reactor and thyristor switch capacitor, which is connected in parallel. Similarly, the same fundamental can be used for the series compensator. So here again, this is the two reactors, two thyristor walls are there, but it is going to conduct either zero value or either zero value or 180 degree. When the firing angle is equal to 180 degree, it means that thyristor is switched off and entire current is going to flow from the capacitor. And second, when the thyristor is conducted, the current is going to divert from the reactor and the capacitor does not come into the series with the transmission line. So it acting as a switch. Therefore, it is called as a thyristor switch series capacitor. A capacitive reactance compensator which consists of series capacitor bank shunted by a thyristor switched reactor. Now, this much part is the thyristor switched reactor. Okay, to provide stepwise control of the series capacitive reactance. When we does not want the smooth control of the capacitor value, we can use thyristor switch. So the cost of this one is smaller as compared to the thyristor control series capacitor. So this is the two basic type of series compensation which we are using in the as a fact device in the transmission line. Okay. Now, second is the thyristor controlled series reactor. Some of the time it is not only to say introduce the capacitor for maintaining the higher voltage, improving the voltage and increasing the transmission line capacity. Sometime because of the Faraday effect. What is the Faraday effect? The Faraday effect is that sometime the receiving end voltage is greater than the sending end voltage, and it is because of the effective line capacitor, isn't it? So when the line capacitor is more and it is giving some in the Faraday effect, then it is possible or then it is necessary to introduce some reactance in the transmission line again to maintain the terminal voltage. So here a thyristor control series reactor TCSR, a inductive reactance compensator which is consist of series reactor shunted by thyristor control reactor in order to provide smooth variable series inductive reactance. So here instead of capacitor, reactor also connected, and by controlling these two walls, it is possible to use to control the effective value of inductor which is connected in series with the transmission line. So this is some series compensator similar to the control TCSR, thyristor control series reactor. It is possible thyristor switched series capacitor. So thyristor switch series reactor. So thyristor switch reactor, a inductive reactance compensator which is consist of series reactor shunted by thyristor controlled switch. Now here it is a control switch only, means either it is going to conduct 100% or either is a off position. So both category is possible. Control category also possible and switching category also possible. In control category, it is possible to obtain the smooth control over the capacitive reactor as well as inductive reactor. And in switched category, it is possible to switch the capacitor in stepwise manner as well as to switch the inductor in stepwise manner. And it is both in the series compensation as well as the shunt compensation. Next, combined shunt and series controller. What it means? It means that whatever the discussion which is independent, either it is a shunt compensation, either it is a series compensation, but it is possible to combine this shunt and series compensation either in independent control or either in the coordination or unified. When there is a unified is there, it is possible to handle the active power with the help of two transmission line in such a way that the loading of the transmission line is optimal, and it is possible to use the full infrastructure of the transmission line, isn't it? So what is that? Combined shunt and series connected controller. A combination of static synchronous compensator STATCOM and static series compensator SSC, isn't it? This is the two major controllers are there. One is the STATCOM, which is connected in parallel, and static series compensator, which is connected in series via common DC link. So we are providing a DC link between the shunt and series, which is used for the reactive as well as the active power control to allow bidirectional flow of real power between the series output terminal of the SSC and shunt output terminal of the STATCOM. So with the help of this coordination control, unified control, it is possible to control the active power also, and are controlled to provide the provide a real and reactive series line compensation without an external energy source. This is a possible. This is the things without an external source. it is possible, means without help of the some storage system, it is also possible to control the active power. Okay, so this is the things which is related to the UPFC, that is a unified power flow control by means of angular analogy and connected in the either it is sorry. Okay, so it means that in case of the shunt compensation, what is that? It is going to shunt compensation, it is going to series compensator, it is going to inject the voltage, whereas the shunt compensation, it is going to inject the current in the point of connection. So whatever the independent two shunt two devices, either it is a shunt or either it is a series, they are connected unified with the help of DC links. So see, this is the STATCOM and this is SSC. Either it may be a voltage source or current source converters are there, sorry, effect controllers are there, and it is connected with the help of DC link. And see, this is the capacitor, so it is a voltage source converters, and it is connected to a single line, that is one for the shunt compensation, one for the series compensation, and it is possible to control in the unified manner. Now, one more thing is that many times we have to change the typing of the transformer. The typing of the transformer is a very effective means as a compensation. If you are going to visit any substation, even 11 kV or 33 kV substation, you find that there is a step change in the we can obtain the voltage change with the help of tap changing of the transformer, and it is connected with the high voltage winding of the transformer. So by changing the tap value, it is also possible to do the compensation, and by shifting phase shifting of the transformer. So there are two type of phase shifting transformers can be used for obtaining the compensation. Okay, so thyristor controlled phase shifting transformer. So here the phase shifting is done. So by phase shifting, definitely it can improve the power handling capacity of the transmission line. So a phase shifting transformer adjusted by thyristor switch to provide a rapid variable phase angle. So whatever this, with the help of this phase shifting transformer, it is possible to change the angle delta, isn't it? And it is done with the help of some controlling device which is connected with the thyristor valves. So thyristor switch, why we are using the thyristor switch? Because it avoid the arcing, it avoid the heavy say switching mechanism. So therefore we are using the thyristor valves are there. In general, phase shifting is obtained by adding a perpendicular voltage vector in series with the phase. So what we are doing, we are adding a perpendicular vector to the existing voltage. The vector is derived from the other two phase via shunt connected transformer. So what we have to do, we have to connect a shunt transformer, and with the help of, we are going to add perpendicular voltage in the phase voltage, isn't it? And by doing this, we are going to understand with the help of some diagram in the, because it is some just a brief discussion of different type of fact devices. So with the help of with the mechanism of this adding of one perpendicular voltage vector in series with the phase, definitely it is possible to change the angle delta, and by angle by changing that angle delta, it can increase the power handling, or we can do it is a one type of controller that can be used in the transmission system. So for today's, I think it is sufficient, and from the next lecture we will see the comparison of HVDC and FACT. It is a very important one, why we are using FACT devices as compared to the HVDC, because HVDC is also have a numerous advantage over the EHV system.